Hello, my name is Emma, and welcome to Design Patterns in Minutes by dpatterns.com. Today, we're exploring the adapter pattern, one of the most practical and relatable design patterns you'll encounter. Think of the adapter as a translator or a bridge. Its job is to let two otherwise incompatible parts of a system work together without changing either of them. In the real world, we use adapters all the time. Imagine you've traveled abroad with your phone charger. The plug doesn't fit into the local socket. Do you buy a brand new charger or change the wiring in the wall? Of course not. You simply use a small adapter that allows the plug and the socket to connect seamlessly. The adapter design pattern works the same way in software. Let's dive deeper. Software systems often grow over time. You might inherit legacy code written years ago, or you may want to integrate a third-party library that wasn't originally designed for your application. The challenge is, their interfaces don't match. One class might expect methods in a certain format, while another offers them in a completely different way. Without the adapter pattern, you'd either have to modify the old code or rewrite entire sections, both of which can be risky and time-consuming. Instead, the adapter provides a thin, specialized layer in between. It receives calls from your system in one format and translates them into the format the other component understands. This way, your existing code remains untouched. The new code stays intact, and yet they can communicate perfectly. Here's a simple analogy. Imagine you're working in a company where the finance team speaks only in spreadsheets, while the marketing team prefers presentations. To collaborate, you could try teaching one team the other's tools, but that takes time and disrupts their workflow. The smarter option is to create a translator who takes the spreadsheet data and turns it into a presentation, and vice versa. That translator is the adapter. One of the biggest benefits of this pattern is reusability. You don't need to abandon valuable existing code just because it doesn't fit neatly into your new system. Instead, you give it an adapter and suddenly it becomes useful again in a fresh context. Another benefit is flexibility. If tomorrow you decide to swap one component for another, you can simply write a new adapter without disturbing the rest of your codebase. Of course, the adapter pattern also comes with a small cost. Every layer of translation adds a little complexity. If overused, your code may feel cluttered with too many adapters. That's why the key is balance. Use adapters to solve clear compatibility problems, but don't rely on them to fix every mismatch. Sometimes a direct refactor is the better long-term solution. To summarize, the adapter pattern acts as a translator between incompatible interfaces. It helps you integrate legacy systems, third-party libraries, or mismatched components without rewriting them. It promotes reuse, flexibility, and smooth integration, all while keeping your existing code safe from unnecessary changes. Thank you for listening to Design Patterns in Minutes with me, Emma. For the full explanation with code examples and diagrams, visit dpatterns.com.